Effects of different spine alignments in the standing position. Due to different physical constitution and daily physical stress, an individual characteristic alignment of the spine is developed in the course of life. Therefore, the double S shape of the human spine is subject to a wide range of variations. To investigate the effects of such different spinal curvatures on the intradiscal pressure, 5 models of the lumbar spine with different lordosis angles are created. In this work, the lordosis angle is defined by the line through the upper end plate of L1 and the end plate of os sacrum. MBS lumbar spine models with different alignments. The model located in the middle has to be understood as a basic model concerning the anthropometrical and biomechanical properties for the further models A, B, C, and D. The basic model has a lumbar angle of 60 degrees, model A of 64 degrees, model B of 61 degrees, model C of 59 degrees, and model D 56 degrees. It should be noted that the proportions in this figure should be understood as an approximation to the real model dimensions. Therefore, deviations can occur from the model. Upright standing of a normal weight person is chosen as simulation case because it represents the natural load case. The models are applied with the weight of the upper body. The force application point is located in the center of gravity. This gravitational force causes a deformation of the intervertebral discs, and a corresponding reaction force in the intervertebral discs is built. Therefore, the average intervertebral disc force, calculated from the different values of corresponding functional spinal units, FSUs, of the 5 models, increases from the lowest FSU to the uppermost FSU. In this context, the term FSU is understood as the smallest physiological motion unit consisting of 2 adjacent vertebrae, the corresponding intervertebral disc and all adjoining ligament. Shows the intradiscal pressure of all functional spine units of the different aligned models in comparison. Because of the different spine alignments, it could be assumed that also the intradiscal pressures of the various models should greatly differ from each other. But this assumption is not immediately evident from. However, the percentage difference of the maximum and minimum intradiscal pressure value of an FSU is determined, and the percentage difference of the FSUs L5 SAC and L4 L5 is 8% and of the FSU L2 L3 even 13%. For the intervertebral discs, the resulting percentages of L3 L4 and L1 L2 are 3% and 5% respectively. Intradiscal pressure of the different aligned lumbar spinal models. To sum up, it can be stated that the individual spinal alignment has an impact on the load distribution of the intervertebral disc.